So today we're going to begin working on the second part of this collection of problems. And you'll notice that in the title up here it says second law single force. That is the last one that should have gone with the previous group, but it didn't fit on the page, so that's fine. We will be transitioning to second law multiple forces. And so that's the collection that we'll be looking at today. There's a total of 8. This first one, which is in that packet that you received yesterday, I am not going to look at right now. I would like you to work this one out on your own. I will tell you that you will need to use the distance and velocity information to find the acceleration. And then once you have that, you can use the mass to find the force that is required. And you might be surprised at how much force it is relative to the fact that it's a 7-gram pellet. So we'll leave that one be and go directly to the first one that I want to use as an example. So we now are going to have to reckon with objects that have more than one force acting on them. And so you'll now see me begin to draw free body diagrams again, as we did last week. And this will help me organize the information so that I can write out Newton's second law properly. So in this scenario, we have a fisherman who's fishing. He hooks a fish, he yanks it vertically out of the water with an acceleration of 2.5 meters per second squared. He has a fishing line with a breaking strength of 22 newtons. So what is the mass of the fish if the line breaks? So here's the basic process we go through. Begin with a free body diagram. In this case, that free body is the fish. There is always a excuse me. See if I can talk. There is always a force acting downwards on the object, which is its weight. So I'll call it W, and that is equal to mg. We discussed this previously, that the weight of an object is its mass times the acceleration of gravity. And then the other force in this case is the fishing line, which is pulling the fish upwards, and we'll call that T for tension, the tension in the line. And so now if I write out Newton's second law, keeping in mind that it is the sum of forces acting on the object equals ma. In our case, we have the tension force plus the weight, which I'll write as mg, equals ma. Okay? And now we start filling in the blanks. The tension we will assume is maximized here in this problem. So it's at the 22 newtons, which is the maximum that the fishing line can hold. In fact, because the line is breaking, we know that it's exceeded 22 newtons, but we'll calculate it as if it were exactly 22 newtons. This is positive because it's the upward direction, and I choose in almost every case to make up positive. Minus, because weight is acting downwards, the mass of the fish, which we do not know, times g, which is 9.8, equals the mass of the fish times the acceleration. Now, what direction is the acceleration?
No, 22 north. Oh, no, sorry.
Not how much, what direction is the acceleration, up or down?
Down.
Let's read the first sentence again. A fisherman yanks a fish vertically out of the water. So it must be accelerating upward, so this would be a positive 2.5.
It's not negative 920? Oh, wait, no, never mind.
The negative is right here.
Oh, okay.
All right, so at this point we need to algebraically find the solution to this. And so we could do something like this. 22 equals m times 9.8 plus 2.5. What I've done is I've added this term to the other side and pulled the m out all in one step. And if we solve that, let's quickly do the calculation here.
It's 12.3, and then if you divide it, it'll be 1.78.
Yes, the mass, I'll go with 1.79. It rounds up kilograms. And again, because the line is breaking, we know intuitively that the mass of the fish is actually greater than this. So I'll just put out here, this is the least, or the minimum. Mass for that. This problem illustrates quite nicely the basic steps that you follow in any of these problems. Free body diagram, write out Newton's second law with the sum of forces, being very careful to keep positive and negative in the correct directions, and then solve the equation that you get as a result. Okay?